In the mid-70s, Soviet aviation was on the verge of a breakthrough. The country had already managed to declare itself with the loud word supersonic when the Tu-144 took to the skies, the pride of Russian engineering, a direct alternative to the Western Concorde. For many, it has become not just an airplane, but a symbol of the future, where distances are halved and Moscow and Vladivostok are separated by only a few hours of flight. But there was a much more complex picture behind this image, where the spectators at the air shows enthusiastically applauded the slender lines of the liner. The engineers saw the figures: overheating, fuel consumption, vibrations, resource nodes. Where there was a comfortable interior and a soft seat for the passenger, there was a constant struggle with the technical limitations and unpredictability of the new car for the crew. And it is this confrontation between a brilliant dream and a harsh reality that will eventually become a drama. While the West was already confidently operating Concorde on transatlantic routes, the Soviet Tu-144 flew only between Moscow and Alma-Ata. There are not hundreds of passengers on board, as originally planned, but only about 80. The reason is simple. There were temporary engines at the heart of the plane, which were too voracious and not reliable enough for long-distance flights. The machine could reach a cruising speed twice as fast as sound, but its range was limited like a bird with clipped wings. And against this background, a new version appears, the Tu-144D, where the letter D meant far. Her task is to give the car a second life, to give the opportunity to fly from Moscow to Vladivostok without landing, to prove that Soviet aviation is capable not only of catching up, but also of outstripping the world. The numbers themselves sounded impressive. 6,500 kilometers with a full load, which in fact opened the door to real intercontinental flights. The spring of 1978 was a turning point. The Voronezh aviation plant assembled the first serial Tu-144D, equipped it with new RD-36-51 engines, and the machine was being prepared for transfer to Aeroflot. For the pilots, it wasn't just a flight, it was the future of the entire program. If the test flights are successful, the country will open the era of regular supersonic passenger routes. But the air in which triumph should have sounded always retains a shadow of risk. After all, each new flight of an experienced airliner was like a step on thin ice. There was a smooth surface outside and a hidden threat underfoot. On May 23, 1978, it seemed that another test was ahead, another point in a long chain of tests. But it was this day that became the milestone after which the word supersonic ceased to sound like a promise of a bright future and became a reminder of the price one has to pay for a dream. When humanity consciously crossed the sound barrier for the first time in the 1960s, the sky no longer seemed to be the limit. It seemed that just a little more and the capitals of the world would be connected by high-speed corridors, where the distance is measured not in days but in hours. In this race for the future, the Soviet Union could not afford to stay on the sidelines. So there was a project that was destined to go down in history. The Tu-144 was conceived not as an experimental aircraft, but as a real passenger liner, the world's first machine capable of transporting hundreds of people at twice the speed of sound. His birth was accompanied by the same atmosphere of audacity and enthusiasm that the Soviet engineering school was famous for. We were able to launch a satellite, we were able to take a man into space, and we will be able to build a supersonic airliner. The first trials were really amazing. Its slender, swift silhouette, sharp nose, capable of pecking down for better visibility during landing, wings with a kink and additional delta ears for maneuverability at low speeds. All this made the Tu-144 look more like a spaceship than a conventional aircraft. He could soar to a height of more than 16 kilometers, where the sky turns dark blue and clouds remain under the wing, like blurred brush strokes. But there was a price behind the beauty. To break into the supersonic realm, the engines consumed a tremendous amount of fuel. The first production vehicles had NK-144A power plants, which were powerful but uneconomical. At full load, the aircraft could fly only a little over 3,000 kilometers, and this despite the fact that routes like Moscow, Khabarovsk required at least 4,500. This is how a paradox arose. The project, born in order to conquer distant frontiers, turned out to be tied to a relatively short route, Moscow-Alma-Ata. Flights officially began on November 1, 1977, and it was an event for passengers. Imagine an ordinary ticket, but you have a boarding pass for a supersonic car that will take you to a place where ordinary planes take twice as long in just 2.5 hours. And yet, behind the facade of triumph, there were limitations. Instead of 150 people on board, there are only 80. Instead of long-distance flights across the country or overseas, there is only one route. Inside, the plane looked like a symbol of progress, but its heart, the power plant, needed urgent replacement. That is why, on the sidelines, back in the mid-60s, work began on a new engine, the RD-36-51. It was supposed not only to give more power, but also to reduce fuel consumption to a level at which supersonic would become practical. The project promised to expand horizons, from Moscow to Vladivostok, from Leningrad to Tashkent, and even further with a special configuration. There was talk everywhere that the new Tu-144D would turn a dream into reality. Newspapers wrote about the air express trains of the future. Engineers were building models for blowing wind tunnels, and factories were preparing for mass production. The atmosphere was such that each test flight was perceived as a step not by one aircraft, but by an entire country towards a future where the sky belongs to supersonic. But there is a hidden edge of risk in every technical breakthrough. The higher the speed, the stronger the vibrations and thermal stress. The thinner the fuel system tubes, the more dangerous any pressure fluctuation is. On the ground, it looked like rows of neat drawings and tables, and in the air, it looked like a challenge that had to be answered by the man at the controls. And on May 23, 1978, just such a call was made. In the early 70s, it became clear that if a supersonic airliner really had to fly far and regularly, not just cosmetic improvements were needed, but a new philosophy of the power plant. The engineers knew that even the most beautiful and fastest aircraft is useless if it is limited in range. The success of the Concorde was largely due to the Olympus engines, which made it possible to work confidently on long-distance routes across the ocean. The Soviet Tu-144, despite the proud title of the world's first supersonic passenger aircraft, was held hostage by the voracious and noisy Mk-144A. In the offices of the Ministry of Aviation Industry and at meetings of the Military-Industrial Commission, the same words were heard: range, efficiency, reliability. It was then, in 1969, that it was decided to create a new modification which would receive the index D, FAR. On paper, everything looked great. With a takeoff weight of 150 tons, the car was supposed to carry 150 passengers and cover 4,500 kilometers. And with an increased take-off weight of up to 180 tons, it was already 6,500 kilometers, which in fact opened a corridor from Moscow to Vladivostok. The RD-36-51 engine became the key to this task. Its development went in parallel with the aircraft itself and lasted for almost a decade. It was a real engineering duel with the laws of physics. The turbine had to withstand the colossal temperatures that occur at supersonic speed, but at the same time remain economical. The fuel supply system was redesigned, taking into account the high pressure and the need to operate in conditions where the aircraft literally crashes into dense layers of air at speeds over 2,000 kilometers per hour. It was this engine that became the basis of the new version, the Tu-144D. On April 18, 1978, the Voronezh Aviation Plant presented the first serial copy, and on April 27th it took off. The pilots noted that the car behaved a little more confidently than its predecessors. The acceleration dynamics were better, the engine sound was a little softer, and the feeling of power reserve was reassuring. After the first flights, the plane was transferred to Zhukovsky, where the Gromov Institute of Physics and Technology, the country's main test site, was located. There he had to undergo a complex of control and acceptance flights. These were not just check-ins, but a detailed study, from the operation of air conditioning systems to the behavior of fuel lines in different modes. There was too much at stake. It was this aircraft that was supposed to open a new page in the history of civil aviation in the USSR. By mid-May, the car had only 5 flights with a total duration of 9 hours. It was a tiny experience for a giant that had to carry hundreds of passengers across the country. But every day the tension grew. A decision was soon to be made on whether to transfer the liner to Aeroflot. On May 23, 1978, only the second acceptance flight was planned. It would seem that the usual procedure is to accelerate to Mach 2. then descend to 3,000 meters and check the operation of the auxiliary power plant. It's a common job that pilots have done dozens of times on other planes. But it is precisely such ordinary flights that sometimes turn out to be crucial. On that day, none of the 8 people on board suspected that the history of supersonics in the USSR would take a sharp turn. May 23, 1978 turned out to be an ordinary spring day in Zhukovsky. There was a slight smell of aviation kerosene on the territory of the Flight Research Institute, and the familiar engine noise created a background to which all airfield employees were accustomed. It was another day of work for the engineers, but for the 8 people who boarded the latest Tu-144D, this flight was a step into history. The crew was led by an experienced test pilot, Eduard Yelin. Next to him are co-pilot Popov, navigator Vizir, flight engineer, and representatives of the design bureau, the very people who designed and assembled the car. Inside the cabin, there were not passengers, but engineers who carefully monitored the instrument readings. Their job was to capture in real time the behavior of systems that would carry hundreds of people in the future. The procedures before departure were proceeding smoothly. System check, engine run, communication channel report. Everything looked normal, even boring. But it is precisely in such a routine that the thinnest edge of risk is hidden, behind dozens of familiar numbers. Sometimes the only one that changes everything is hidden. At 17:30, the crew received permission to take off. For RD-36-51 turbojet engines came to life with a low rumble, gradually turning into a roar. The giant weighing more than 150 tons began its run-up along the concrete strip. At a speed of about 300 kilometers per hour, the front pillar lifted off the ground, and the plane soared into the sky. Acceleration to supersonic was uneventful. The Tu-144D gained altitude. The speed smoothly passed through the barrier m=1 and then stabilized around m=2. For a passenger liner, it was a real space. The sky was getting darker in the portholes. The wings were cutting the air like a knife on water. Everything happened as planned by the designers. The task for that day looked simple: to check the auxiliary power plant at an altitude of about 3,000 meters. This device is essentially a small jet engine that is fired to provide the aircraft with energy and compressed air on the ground or in emergency situations. Checking it in flight is a necessary step before putting the airliner into operation. When the crew began to descend, the instruments recorded an oddity. The flight engineer noticed a discrepancy between the fuel meter data and fuel consumption. The difference was almost 5 tons, too much to attribute to an error. But instead of sounding the alarm, he just adjusted the numbers. There was a sense of calm in the cabin. Yes, there was a slight sensor malfunction, nothing critical. At 18:45, the pilots began preparations for the launch of the auxiliary installation. The speed was reduced to 500 kilometers per hour. The altitude was 3,000 meters. Everything was going according to plan. But suddenly a red light came on the panel, and the voice informant issued an alarming message: "Fire!" And at that moment, the calm, casual atmosphere of the test flight was replaced by an alarming one. For the crew, this was the first signal that the day of the inspection was turning into a day of struggle. In the cabin of the Tu-144D, the alarm sounded like a short bell, a dry signal from the fire system, followed by the voice of an automatic machine: "Check the engine." The red light on the panel flashed on opposite the third engine nacelle. The flight engineer reacted instantly, shut off the engine, and activated the fire protection system. Everything in the cabin looked organized and even calm. The fire was localized. The crew was acting according to instructions. But already in those seconds, a chain of events that could not be stopped began behind the steel casing. The pilots turned the car around to head back to Zhukovsky. The speed was around 500 kilometers per hour, and the altitude was about 3,000 meters. Everything looked different from the ground. Eyewitnesses later said that a long trail of fire stretched out from under the wing, like a torch that did not fade for a second. What seemed to be a signal and reaction in the cabin looked like a rapid spread of flames from the outside. Co-pilot Popov requested a direct approach from air traffic controllers and fire crews at the runway. At first, the crew even hoped that it might be a false alarm. But the smoke that began to seep through the air conditioning system quickly dispelled any doubts. A black curtain crept along the starboard side of the cabin, burning his eyes and lungs. Yellen, as the commander, tried to keep control of the situation. In his memories, there was an almost physical rage at the fact that the car, intended to become the pride of the country, was turning into a burning torch. But even at such moments, he acted coolly. He kept the course, controlled the speed, and gave commands in a clear voice. The fire alarm went off again soon after, this time on the fourth engine. The flight engineer started the second extinguishing line, and another turbine went silent. Now the plane was flying with only 2 engines on the left side. There was enough thrust, but the control margin was dwindling before our eyes. The black smoke was getting thicker by the minute. To improve visibility, the pilots lowered the nose, the famous movable cone that allowed the Tu-144 to nod nose down. But instead of relief, they received a new blow. A stream of smoke poured through the ventilation into the cabin, and the dashboard turned into a dim, barely discernible spot. The crew was faced with a choice: to continue heading for the airfield or to look for an emergency landing site directly ahead. Popov offered to sit on the field, but Yellen objected at first. There was still a chance to reach Zhukovsky's concrete. However, the situation was getting worse by the second. When another engine died, it became clear that the car was turning from an airliner into a glider, and there was less and less time left. And it was here that the dual nature of this machine manifested itself. On the one hand, it's a supersonic giant, built for speed, beautiful and powerful. On the other hand, it is a vulnerable organism, where a single spark in the fuel system can disable the entire structure. The Tu-144D was going down like a giant engulfed in flames. There was acrid smoke in the cockpit, and the instruments behind it were barely distinguishable. But the pilot's hands continued to work with a precise, honed sequence. Every movement was measured, as if time had slowed down around them. The plane was losing altitude, and every meter brought it closer to the crucial moment. The entire starboard side was already on fire, and the engines were shutting down one by one. First the third, then the fourth, then due to overheating I had to turn off another one. Soon, all the thrust was held by only one left engine. It seemed that this was not enough to control such a huge thing, but the plane still obeyed the rudder. This was an unexpected confirmation of the strength of the structure. At some point, the electrical system also started to fail. The generators have shut down, and the only power left is from the batteries. The secondary indicators went out in the cockpit, but the main thing remained: the steering wheel in his hands and the inertia with which he could reach the ground. Commander Yellen later admitted that rage was growing in him. Not fear, but anger. Anger at the fact that the first production copy, which was supposed to open a new era, turned out to be a helpless torch. He knew there was no chance of saving the car, but he refused to let it fall into chaos. Even in the smoke, he held the steering wheel as if a single effort of will could keep metal from shattering. Co-pilot Popov insisted on landing in a field. In front of them stretched the marshy areas of the Moscow region, overgrown with grass and shrubs. They could be used to try to attach the car, avoiding urban areas. Yellen argued at first, but the smoke thickened so quickly that even he realized he couldn't reach Zhukovsky. The dispatchers on the ground heard their conversations, heard requests to prepare the runway and fire crews, but at the same time they were already receiving messages from eyewitnesses. The plane is on fire, a torch is trailing it. For ground-based observers, it was a spectacular, almost fantastic nightmare. For the crew, it's a concentrated struggle on the edge of possibilities. In the cabin, every breath was a challenge. In order not to suffocate, the pilots used a technique familiar from overload training: a short, sharp exhalation with tension, as if using muscle strength to push smoke out of their lungs and suck in some clean air. It was more like a survival instinct than a technique, but it worked. Yellen looked at the instruments through the fog and kept one thought in his head: if the car was not destined to remain intact, then at least let it sit down controllably. Let it be seen to the end that a person is able to fight even when fire has already defeated metal. And now an area that could be mistaken for salvation appeared ahead. A long clearing, slightly swampy, but without large trees and buildings. The plane was traveling at a speed of about 400 kilometers per hour, dropping to a height of only 1,500 meters. There was no more time to think, only to act. The fire giant was rapidly descending, approaching the chosen clearing. Residents of the nearest villages could already see it from below. A long torch, clouds of black smoke, the roar of turbines that were still working with their last strength. But for the 8 people in the cockpit, it all came down to a point in front of them. A narrow strip of swampy land, the only chance to save the car and themselves. Yellen steered the plane smoothly, aligning it as much as possible relative to the horizon. The altitude is only a few meters, the speed is about 400 kilometers per hour. At such a mass and in such a condition, any sudden movement would mean the inevitable collapse of the structure. The plane was flying almost in glider mode. The nose cone was lowered, smoke still filled the cabin, but the steering wheel was in his hands, and this remained the main thing. At an altitude of about 5 meters, the liner touched the ground. Not the landing gear, they were not released, but the lower part of the fuselage. The impact rang out with a boom that went through the entire cabin, like the crack of a giant string. Metal grated on the ground, and the car made a long furrow in the swampy soil. The Tu-144D continued to slide along the belly for almost 1.5 kilometers. With every passing second, fire surrounded him, enveloping his wings and tail. But despite everything, the hull held up. There was no explosion, no tearing apart. The huge liner, although sparkling, remained intact. The crew kept the nose elevated to the last in order to slow down the slide and avoid an acute angle impact. Only at the end, when the inertia was almost exhausted, the front part sank and crashed into the ground. The nose section crumpled, the seats in the cockpit fell off, and for a moment it seemed that everything was over. But in the next instant, it became clear that life was still clinging to this pile of red-hot metal. The commander, co-pilot, and navigator managed to escape through the emergency exits in the cockpit. They were followed by the engineers in the cabin. They climbed out the front door, making their way through the smoke and heat as the fire consumed the paneling. Only 2 people were unable to leave the car. At the moment of impact, they were trapped in their seats, and it was no longer possible to free them. From the outside, the plane looked like a charred giant that had crashed in the middle of a field near Moscow. The time was 1856. Fire crews reached the place a few minutes later, but by that time the flames had already completely engulfed the liner. And yet the fact remained that the supersonic passenger plane, engulfed in flames, managed to make a controlled landing and save the lives of most of the crew. The contrast was almost symbolic. On the one hand, it was a disaster, the end of the test flight, which was supposed to be the next step towards operation. On the other hand, it is an incredible confirmation of the strength of the structure and the skill of the pilots. The car, which was supposed to carry passengers across the country, was now lying in a field, but at the same time proved that even in a fire and with multiple failures, it remains controllable to the end. When the flames began to subside and the first fire crews reached the clearing, they saw an image that was difficult to relate to the passenger liner of the future. The majestic Tu-144D lay on its belly, blackened and twisted, like a giant struck down by its own elements. The fire burned out the wing, wrapped the tail in a fiery crown, but the fuselage, despite everything, remained intact. The crew got out almost by a miracle. Yellen, Popov, navigator Vizir, and 3 engineers managed to leave the burning car through emergency exits. They were burned by the smoke, weakened by the heat, but still alive. 2 of their colleagues, engineers Venediktov and Nikolaev, remained in the cockpit. At the moment of impact, the chairs broke off from their fastenings and crushed them, making it impossible to get out. The pilots tried to return inside, but clouds of black smoke and fire prevented them. At that moment, the realization came. The struggle was over, and the price had already been paid. Not only human, but the price of the program, the dream of the future that was to come with this plane. After all, the first production copy of the Tu-144D, intended for transfer to Aeroflot, turned into a pile of ashes in a field near Moscow. And yet, there was a paradoxical element of victory in this defeat. The design withstood what no passenger liner of that time could have withstood. A massive fire in flight, multiple failed engines, landing on its belly in a swampy area. No explosion, no complete destruction, just a charred but whole hull. The very fact that most of the crew was able to survive showed that even a supersonic car designed for speed limits had strength and stability. However, for the program as a whole, it was a blow from which it has not recovered. After all, if the first production model, a symbol of the future, did not stand up to the test, then how can hundreds of lives be trusted with regular flights? The doubts that were already hovering around the project have now become arguments. The field near Moscow has become more than just an emergency landing site for the Tu-144D. It became the boundary that separated ambition from reality. It was here that the confidence ended that supersonic would become a mass transport. The day after the emergency landing, the field in the Voskresensky district already resembled an open-air laboratory. Dozens of specialists worked around the black building. Representatives of the Tupolev Design Bureau, engineers from the Voronezh aircraft factory, and military experts. Trucks with equipment were parked a little further away, and right in the cabin and engine nacelles, investigators were dismantling the remains of charred pipelines and wiring. Everything had to be fixed. Every centimeter, every fuel stain, every broken rivet. The work was supervised by a commission of almost 100 people. Their task was not just to find a scapegoat, but to determine the real reason why the newest liner turned into a torch. After all, the Tu-144 has already been used on passenger flights, and a repeat of such an incident on a regular flight could have much more serious consequences. The flight data recorders confirmed that the fire started precisely at the time of the launch of the auxiliary power plant. But the main question remained, where did so much fuel come from in its circuit? Tests showed that the leak occurred at a tremendous rate, up to 220 kilograms per minute. About 8 tons of kerosene were lost during the entire flight, and it accumulated in the wing niches and engine nacelles. One spark from the launch of the installation was enough to turn the plane into a torch. The first bench tests yielded unexpected results. The pipelines revealed phenomena that had not yet been described in the aviation literature. Fuel fluctuations with a frequency of more than 1,500 Hz. For comparison, the engineers were counting on a maximum of 100 Hz. It turned out that each tube inside worked as a resonator, being exposed to its own liquid. These micro-vibrations destroyed the metal from the inside. Fatigue cracks appeared in the joints, and at high pressure in the mains, this turned into a leak. The situation was also aggravated by technological procedures. When flushing pipelines, a two-phase flow was used, which additionally reduced the metal resource by almost half. The Commission also identified another feature. There were water shocks in the fuel system, much stronger than expected. In supersonic flight, they were comparable to sledgehammer blows on the walls of the highway. Combined with vibrations, this has become a deadly cocktail for pipelines. In fact, it was a new, hitherto unknown aviation problem. There were no calculation standards for such fluctuations in the Soviet documentation. That is why the design turned out to be vulnerable. Engineers designed the system according to one parameter, but the reality in the air dictated completely different laws. By the end of the summer, the Commission submitted a final report. The cause of the accident was found to be a fuel leak in the nacelle area caused by the loss of tightness of the fuel pipelines. The fire started at the moment of launching the auxiliary installation, when kerosene vapor ignited and engulfed several systems at once. But at the same time, the report also contained an important caveat. Despite the large-scale fire, the aircraft remained controllable to the end. This meant that the problem was not in the aerodynamics or fuselage design, but in one system, the fuel system, and it was she who needed to be redone. The Commission's conclusions sounded like a diagnosis. The Tu-144D, which was supposed to be a turning point in the history of civil aviation, turned out to be an example of how a seemingly small detail can negate a global project. Yes, fuel pipelines have been strengthened, cleaning methods have been changed, new strength standards have been introduced, and fatigue vibrations and hydraulic shocks have been learned to take into account. The engineers drew conclusions, and the system was brought to a safe level. But the trust of passengers, the trust of the state, the trust in the very idea of regular supersonic transport proved impossible to regain. After all, the Tu-144 was already walking on thin ice. Already the first passenger flights in 1977 to 1978 showed that operation is economically questionable. The cabins were not fully filled, and the cost of one flight exceeded all reasonable limits. While Concorde proudly sailed the ocean, connecting London and New York, the Soviet liner served only one route from Moscow to Alma-Ata. It looked more like a demonstration of capabilities than a real transportation system. The disaster on May 23rd was the last straw. The first production aircraft, which was supposed to go to Khabarovsk, remained lying in a field near Moscow. And with it, the hopes for the future of the supersonic Aeroflot were buried. They were still trying to save the program. The Tupolev Design Bureau was refining designs, looking for new application schemes, and even discussing the use of the Tu-144 as a flying laboratory for testing space systems. But the role of a passenger liner was completely lost for him. After a few years, all scheduled flights were removed, and the machines began to be stored or used in isolated experiments. The contrast was almost painful. Yesterday, the newspapers wrote about the Air Express trains of the future, that residents of Vladivostok will have to have breakfast in Moscow and have dinner at home, flying across the country in a matter of hours. And tomorrow, the same lanes that were being prepared for supersonic landings were met only by the usual IL-62 and Tu-154. The dream of flying twice as fast as sound has returned to the pages of technical magazines and to the layouts of air shows. Supersonic remained a possibility, but ceased to be a reality. The field near Moscow, where the first serial Tu-144D completed its flight in May 1978, has become a kind of monument to two things at once: the audacity of a human dream and the price you have to pay for it. Where a few hours ago a snow-white hull with polished lines shone, a charred giant lay surrounded by traces of fire. But even in this state, he didn't look defeated, more like a tired giant who took on the burden of the future too soon. The history of the Tu-144 will always be ambivalent. On the one hand, this is a victory for the engineers who were able to create the world's first supersonic passenger liner, a car ahead of its time, as bold as the idea of flying faster than sound. On the other hand, it chronicles the struggle with physics, with economics, with one's own reliability. The plane, which became a symbol of striving for the impossible, at the same time turned out to be a symbol of the fact that progress without a margin of safety can turn into disappointment. And yet the Tu-144 left a mark that cannot be erased. Its cabins are now in museums. Its outlines are woven into the memory of an entire generation. He inspired engineers and posed questions that aviation is still looking for answers to. And his tragic page on May 23rd reminds us, every spark, every mistake in technology can turn into a fiery trail in history. But it is precisely such stories that make aviation alive. Not only stories of triumphs, when cars take people to new horizons, but also stories of struggle, when people, engulfed in smoke and flames, hold the steering wheel until the last moment. Because ultimately, supersonic sound is not just about speed. It is the courage to dream of the impossible, even if the path to this dream lies through trials that not everyone can pass.